All right, you are welcome again. All right, today let's talk about exact equation. I know in our previous videos we have discussed about this exact equation, but in these new lessons, I'm going to take my time, not actually take my time, but I'm going to tell you or show you how to solve exact equation within seconds. How to solve exact equations within seconds. Once you verify that an equation is exact, within a minute or within some seconds, you should be able to solve it. Okay, now let's go. In our previous videos, we have talked about the method that will take you a whole lot of time, but in this video, it's very, very short. Okay, now let's go. Let's see this question. This question says we should show that this equation is exact and we should solve it. Okay, the equation is 2xy minus 3x squared in bracket dx plus x squared minus 2y in bracket dy is equal to 0. Okay, so we are to show that this particular equation is exact and then we are to solve it. Now, going by definition, what do we mean by exact equation? We said that a differential equation of this form, m of x comma y dx plus n of x comma y dy is equal to 0. Equation of this form is said to be exact if the partial derivative of this m with respect to y is the same as the partial derivative of this n with respect to x. Hello. Now, let me break this down. We have equation of this form. There's a part that has the x and there's a part that has the y. So the part that has the x, we're going to call it a letter m. And the part that has the y, we're going to call it a letter n. So when we differentiate the part that has the x with respect to y, and then we differentiate the part that has the y with respect to x, these two derivatives should be equal. Hello. When these two derivatives are equal, then we say that the differential equation that this m and n are coming from is called an exact equation. Now let's go. Let me just show you with this problem we are solving. Let's solve it. Then we'll see exactly what I'm trying to say. Okay. So now we have said it by definition that this m dx plus n dy is equal to 0, which is an ordinary differential equation. All right, so we say that this type of equation is said to be exact if when we differentiate n partially with respect to y, if it is equal to the partial derivative of n with respect to x. Okay, now let's go. Let's try it. Now in this our equation where we have 2xy minus 3x squared dx plus x squared minus 2y dy is equal to 0. So the part that is having dx, let's call it letter m, right? So that means we're going to have m is equal to 2xy minus 3x squared. This is the part that is having the x, right? Call it a letter m. And then on the other side, we have n is equal to x squared minus 2y, right? Yes. So on this m now, let's differentiate partially with respect to y. So differentiating partially with respect to y, meaning any variable that is not y, we are going to consider it as a constant. We are going to regard it as a constant. Are we together? So this is partial derivatives. Now, we have m is equal to 2xy minus 3x squared. Differentiating partially with respect to y. Let's go. When we differentiate 2xy with respect to y, we are going to have 2x. And when we differentiate minus 3x squared with respect to y, there's no y here. So meaning all of this is a constant. It's going to give us 0. So therefore, the partial derivative of m with respect to y is equal to 2x. Good. Now let's go to n. The partial derivative of this n with respect to x. Differentiating n with respect to x partially. Now, when we differentiate x squared with respect to x partially, it's going to give us 2x. And then when we differentiate minus 2y partially with respect to x, it's going to give us 0 because there is no x variable there. All right. Now, looking at this, we see that the partial m all over partial y is equal to partial n all over partial x. Hello, meaning that these two partial derivatives are equal. Thus, we say that the equation is exact. By definition, we found out what exact equation mean, and here we have tested it, and we discovered that both partial derivatives are equal, meaning that the equation that these two m and n are coming from is exact equation. Are we together? Good. Now, how can we solve this equation now? How can we solve this? Now, for us to find the solution to this particular equation, differential equation, we are going to look for a function, let's say u of x comma y. Now, this function u of x comma y, it should be a function in such a way that when you differentiate this u partially with respect to x, it's going to give you m. And when you differentiate this function u partially with respect to y, it's going to give you n. So when we find this particular equation, when we find this particular function u of x comma y, such that when you differentiate it partially with respect to x, it will give you m. You see this m that we have, and when we differentiate it partially with respect to y, it will give you n. So that particular function is the solution to this differential equation. How can we go about it? Now look at this. Pay attention. We said we need a function called u of x, such that when you differentiate it partially with respect to x, it will give you m, and when you differentiate it partially with respect to y, it's going to give you n. Are we together? Good. Now look at this. We said the partial u of partial x is m, partial u partial y is n. What if we integrate both sides? So integrating both sides. Now this side that has partial u partial x, what if we integrate it with respect to x? So that means we are going to have the integral of partial u partial x with respect to x, and the integral of m with respect to x. Now let's apply it to the other side. The integral of partial u partial y with respect to y is equal to the integral of n dy. Now let's go. Now in this place where we have the integral of partial u partial x dx, so this dx partial x we cancel, right? We're going to have the integral of partial u is equal to the integral of m dx. Now the same thing happens to the other side. We're going to have the integral of partial derivative of u is equal to the integral of n dy. Hello, I don't know if you are getting what we are trying to say here. Now look at this. Pay attention to this. We have the integral of partial derivative of u. Derivative of u. When you take the integral of a derivative, it will remove the derivative. So we are going to have u. Okay? Good. Now when you try it here, we are going to have u is equal to the integral of m dx. And then u is equal to, again, the integral of n dy. So add these two together. We're going to see that u that we are looking for is the integral of m dx plus integral of n dy equal to 0. Hello. So there is no need of us going to a long process What we just need to do is pick your m, integrate it with respect to x, pick your n, integrate it with respect to y, bring these two terms together. That is the solution to the differential equation. Hello. Now let me try. Let's see what we are trying to say. From the equation that we have, we see that m is what? Is 2xy minus 3x squared, right? And then our n is x squared minus 2y, right? Now let's integrate m with respect to x, integrate n with respect to y. We are going to have the integral of 2xy minus 3x squared dx plus the integral of x squared minus 2y dy equal to 0, right? Let's put it differently like this. So here, when we integrate with respect to x, where we integrate 2xy with respect to x, we are going to have 2x squared y all over 2. And when we integrate 3x squared with respect to x, we are going to have 3x cubed all over 3. Now, the other integral with respect to y now. When we integrate s squared with respect to y, it's going to give us y s squared. When we integrate minus 2y with respect to y, we're going to have minus 2y squared all over 2. Then let's add a constant, plus c equal to 0. Are we together? Good. From this side now, look at these two integrals that we have. Let's simplify it. So here we have 2x squared y all over 2. When you simplify this, we're going to have x squared y, then minus this 3x squared all over 3. Simplify it, we're going to have minus s cubed. Then we have plus. The other side we have x squared y minus. Here we have 2y squared all over 2. Simplify it, we're going to have y squared. Then plus c. Now if you look at this carefully, you see that x squared y appeared twice. So we are going to pick one of it. So we are going to have x squared y minus s cubed minus y squared plus c is equal to 0. Thus, this is the solution to the differential equation 2xy minus 3x squared dx plus x squared minus 2y dy equal to 0. Hello. I think it's very, very simple, right? So this is exact equation made easy. It's actually very, very simple and very easy. And the reason why it took us a long time like this is because we are trying to understand the basis of exact equation. By the time you have this basic knowledge, then it will be very easy for you to solve any problem. All right. Yes, thank you very much for watching. Please, let's take more example. Let's go.